All right, for problem number 2, we're given this square, ABCD, and it says that all of the angles are right angles. And it looks like we're given some measurements here too. So we can assume that this is sort of measuring 1 unit, 2 units, 3 units, 4 units, 5 units, and again 1, 2, 3, 4, 5 units up as well. So it's a 5 by 5 square. And the question asks, what's the percent of the square that is shaded? Well, on this one, my hint to you would be to impose a grid on this. And you can kind of see it's already, if you were to extend these lines across, let me see if I can make sort of straight dashed lines here. If you were to extend these lines, it would almost be like it was drawn on graph paper. Okay, so I'll just extend those across. And let's see if I can do it here as well. So let's see. I can draw some dashed lines down like that, and down like that. Okay, so we've now imposed a grid on this. So it's almost like it was drawn on graph paper now. And that will help you count up the total area and the area that's shaded, and then you can calculate the percent of the square that's shaded, right? Because the percent of the square that's shaded would just be the area shaded over the area, the total area, right? And that's going to give you some fraction, and you want to find out how many out of 100, so we multiply by 100 to get the percent. Okay, so let's work that out. Let's take a look at, now we know that if this is a 1 by 1 square, we know the area of this is 1. And then basically we know that all the areas of these little squares that we've broken this down into are all 1, right? So if we know that this is a 5 by 5 square, then the total area is what? It's just 5 times 5, which is 25, right? So we have 25. If we counted up all the little squares across here, then we would have 25 of them, right? And then we want to know what percent is shaded, so there's a couple ways we could think about that. We could count up the number of shaded squares directly. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the area shaded, this should have been a D up here, looks like, is 15. But sometimes it's easier to count what we don't want and subtract it from the whole. And that's called complementary counting. In this case, it really doesn't matter. You could do either one, but we have a little less area that's not shaded. So if we found the area not shaded, it's just fewer squares to count, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10, and what we could have done to find the area shaded is to take 25, the total, and subtracted 10. But it's the same thing. But it's good to have those different tools in your belt and be able to use them, because sometimes it is a lot easier to count what you don't want than it is to count what you do want. Okay, so sometimes you have to take that strategy. In this particular case, it doesn't really matter too much. So We have the area shaded, we have the total area, so we can take 15 over 25, and you can see that that can be reduced. We can divide top and bottom by 5, so that's 3 out of 5. Now we want to know how many out of 100, so we can actually multiply this by 20 over 20, which is just 1, and we would get 60 out of 100, which is 60%. Or, like I had said up here, is you could take the 3 out of 5 times 100, and that'll give you the percent directly. So I can actually divide 100 by 5, and I get 20, and that gives 60 directly, 60%. So either way, the answer is 60%.